Hello guys, myself Bharat and my teammates are Mahesh and Lasya. We have done an internship at the Emertex which is based on embedded systems. We have done our own project of microwave oven simulation which are taught at the Emertex internship. Let's move on to the contents of the internship. The major contents of the internships are introduction to the C programming, data representation, data type, modifiers and qualifiers, conditional loops, arrays, pointer, string, functions, and introduction to the embedded systems, microcontrollers, MPLAB XIDE, XC8, and PixSimsLab, and also for the introduction to the various peripherals of 16F877A. The major requirements of the project are MPLAB XE IDE, a major microcontroller for running the projects, and XE8 compiler, PIX 1658778, and PixSimLab for the simulation purpose. The table of contents that we are majorly focused on: what is an embedded systems, categories of embedded systems, embedded C, microcontrollers, and the project overview and summary of the project. Let us first focus on the what is embedded systems. Embedded system is a combination of a computer hardware and software designed for a specific function. Example, a fire alarm is an embedded system which is meant for a specific purpose. The most of the things that we are using our daily lives are based on the embedded systems. Majorly you are using your mobiles, TVs, mouse, laptops. That is the function of this. Those systems are done through the embedded systems. The major trends in the embedded systems are system on a chip, field program gate array FPGA, automation, IoT, security, low power consumption, high speed, etc. This by through the embedded systems we can make up the simple chips, smaller chips that is running faster and make the size of a device will be less. What is embedded C? Embedded C is the most popular programming language in software field of developing an electronic gadgets. Advantages of the embedded C are easy to understand, high reliability, portability, and scalability. Microcontroller. Microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input and output peripherals on a single chip. The difference between the microcontroller and a microprocessor. Microcontroller is the heart of the embedded system. Microprocessor is the heart of the whole system. Microcontroller is a less cost effective. Microprocessor is a not as cost effective. Microcontroller is a power saving mode in generally offered. In microprocessor, power saving mode is not generally available. In microcontroller, it runs at a relatively lower speed. Microprocessor runs at a higher speed. The project peripheral. This will be explained by my partner Lasya.
Myself Lasya. Next one CLCD. CLCD stands for Character Liquid Crystal Display. It has two type of mode for communication, 4-bit mode and 8-bit mode. In Pixim Lab, there are two types of display, 16:2 display and 16:4 display. It has two types of mode for communication, 4-bit mode and 8-bit mode. Tactical switch. It is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and time in our project. This switch produces a bouncing effect when a switch is pressed. Next is matrix keypad. It is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of users input are required and still want to save some controller input lines. These keypads are used mostly in telephone, calculator, digital lockers, etc. In the right side, you can see the uh, tactile switches are connected row and columns. Interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attend the request. It goes back to the processing where it got interrupted. Polling. Polling is a process where the computer or controlling device wait for an external device to check the readiness or state, often with low level hardware. ISR. ISR, it attends the request of an interrupting source, clear the interrupt flag, should save register content that may be affected by the code in ISR, must be terminated with the instruction RETFIE. When an interrupt occurs, the MPU completes the instruction being executed, disables the global interrupted enable, return from interrupt. Timers. Timer is a default peripheral which maintains the timing of an operation in sync with the system or external clock. It has many applications such as measuring time and generating delays. Timer or counter is a software designed to count the timer interval between the events. Mode of timer or counter, PWM or pulse generator.
So my name is Mahesh. I'm doing the Emertex internship, and this is my project on microwave oven. And we have built the code with the help of Emertex guides, and we have written the code. And we have built it successfully. And we're going to simulate using the Pixim lab. And in the file, we're going to load the X file. And you can see that it is powering on. And we can see the cooking modes, which are micro, grill, convection, and the last is start. And we're going to choose micro cooking mode by pressing 1. And we can see that the power is 900 watt. And we can set the timers, and we set it for 5 seconds, and press hash for enter. I can see the fans have started to run, and we can pause by pressing button 5. And we can also pause by resume by pressing 4. So buzzer indicates a stop operation, and we're going to choose grill by pressing button 2, and we're going to set the timer for 9 seconds and press enter. And in this process, if we try to open the door in the middle of the process, so the buzzer goes off when we close the door, and now we can stop the process by pressing 6, and we choose the convention process by pressing the button 3, and the temperature must be below 250. If we give the temperature like above 250, like 300, and we enter, we get an invalid temperature. So let us give the temperature which is less than 250, like 200, and we enter. So we can see the preheating time is 180 seconds, and the time, let us wait till the completion of the timing of a preheating time. So we just wait for another 10 more seconds for the completion of the convection process. And we're going to set 5 seconds for the actual eating process, and let us wait for the completion of the time. The buzzer indicates the stop of operation, so we're going to press 4 for the start, and we can see that already 30 seconds has been loaded. And if we press again 4 button, again the 30 seconds will be added to the previous time, and we're going to press 6 for the stop of the operation. And that's it for the simulations, and thank you.